look at the concept of distance and displacement, right? Distance, displacement. Now, what are these both? Basically, our distance is the path followed. You can say a path covered by a body. Path covered by a body that is known as our distance, right? Now, what is displacement? Basically, this distance does not require any direction. If a body, like if a quantity does not require a direction, it means it is a scalar quantity. It is a scalar quantity. It does not requires the direction. Direction is not required in this. Direction is not required in this, right? And its unit will be its unit will be its unit is meter, right? Meter is the unit of distance. Now let's talk about what is displacement basically. What is displacement? Basically, displacement is or you can say that it is the shortest distance. The shortest distance covered by a body is known as displacement. The shortest distance covered by a body is known as displacement. Now, basically, or you can say change in position. Change in position is known as displacement. It is known as displacement. Let me increase font size. Right. Okay. Change in position is basically known as displacement. Right? Now, for example, I'm a kid and I am going from my school to my home. So basically, there are two ways. Either I will go by road. Obviously, I'll go by road. I'll go from here, then here, then here, 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 and finally I'll reach my home. Right? So this is a one distance. This is a one path with by following this I can go at my home. Right? Now the path which I followed over here is known as my distance. That is known as my distance. Now what is displacement? As I said you that displacement is basically the shortest distance. So you can see I can go directly from here to here. So is known as my displacement. This is known as displacement, right? Shortest distance known as displacement, right? Now, okay. Now, one thing to remember is that distance can never be distance can never be zero. Distance can never be equal to zero. How? For example, okay, if I'm going from here, 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 and here, obviously I cover some distance, but okay, this displacement can be equal to zero. Displacement displacement can be zero. It can be -2. It can be -2, even though it can be +2. This displacement can be zero, negative, and positive. How I'm saying this? For example, let's draw another diagram. Okay, let's see this diagram. I guess this diagram will explain us. Okay, so here we have the diagram. Okay, so basically this is showing the difference between the distance and the displacement. Like for example, if I'm going from here, this is my distance, right? I'm going. So this is my distance, but the path which I can directly reach me to the end point is this one. So this is known as our displacement. That I was up to. Let me draw a diagram by myself. So for example, okay, this is my initial point. This is my initial point and going this is a distance covered by me, and I'm again returning to the same point. Right, I'm again returning to the same point. It means what will be distance? So this will be the distance. I am covering this distance. What means distance will be something, right? Distance will not be equal to 0. Distance will not be equal to 0. But what about displacement over here? As I said, what is displacement? Displacement is the shortest distance. How we see this? From initial point to final point. What's the distance from point to final point? That is known as displacement. So our initial point is this. This is our initial point, and this is our final point two, right? So it means there is no any kind of initial and final point distance. So it means here displacement. Here the displacement is equal to 0. The displacement equal to 0, but distance not equal to 0. Okay, there's another concept which I can teach you is, okay, that's quite common and come in MCQ. I've seen many times that question. Okay, for example, I'm moving from here. This is my scale. This is my scale basically, right? Okay, this is 1, this is 2, this is 3, this is 4, and this is 5 basically, right? And for example, I am moving, for example, this is my initial position. This is my initial position, and I'm moving from here 5 to, right? So here, as you see, I am moving a straight path. Here my displacement and distance both are equal. When I will say that here my distance and displacement both are equal, right? What I got it from this, that my distance is equal to my displacement. Distance is equal to displacement. But what if I am moving from here? Okay, this now moving, I'm coming back. Now I have stopped over here. Now this is my final position. This is my final position. It means that my distance has now increased, right? First of all, before my distance was for here, if my distance was 5, now it has increased. 5 plus 2 is equal to 7. Now my distance is basically, my distance is equal to 7, right? My distance is equal to 7. What about my displacement? My displacement has been decreased, right? Now what is displacement? From initial point to final point, right? As you can see from here, my displacement is on here. This is my displacement. The shortest distance is my displacement. So from this I can conclude one more thing, which is, let me write it somewhere. Okay, let me write over here, that distance can be equal to displacement, right? Can be equal to displacement. But as you can see, displacement can be less than distance, but distance can't be less than displacement. It means that, or you can say distance oh, I want some manual operations over here. Okay, where I can find that one. Let me make it. Distance will always be greater than the displacement. Either both will be equal, or displacement, right? So distance will be greater than the displacement, but displacement cannot be greater than distance. So these are the both conditions which come. Distance is equal to displacement, or distance is greater than displacement. Or if we know that this distance can never be equal to 0, it will never equal to 0, but the displacement can be equal to 0, or even though it can be negative, or it can be even though positive, can be positive too, right? So I hope concept is clear. One more important thing, that time, the distance will always increase or it will remain constant, but the displacement can decrease too. For example, let me erase this one, right? So for example, okay, I'm moving from here to here at the time is passing. I have uh, I have reached over here. My distance and displacement are equal here. But if I'm moving back, I'm coming over here. Time is obviously increasing, but before my displacement was from here to here, right? But now my displacement is from here to here. Means my displacement is decreasing with time. So distance will not decrease with time. Let's write it to that. mm, Distance mm, distance will never decrease with time, but displacement can decrease with time. Right? Distance can decrease with time. So I hope the concept is clear to you of distance and displacement. If you have any kind of theories, so you can comment down in the comment section. I would be very happy to answer you guys.